Hello guys, today in this tutorial we will see the operators in Verilog. So how and what are the different types of operators are available in the Verilog for implementation of the logic circuits that we're gonna see. So there are different types of operators such as arithmetic operator, logical operator, relational operator, equality operator, then bitwise operator, reduction operator, shift operator, concatenation operator, replication operator, and conditional operators. So taking an example one by one, we'll see how these operators perform. For example, equality operators are used for comparison, relational operator are used for comparison if it is less than, equal to, or greater than the respective numbers. So today we're gonna see a bitwise operation. So bitwise operation in Verilog code, we're gonna see it, and then we'll proceed for further with some more different number of examples. So for next tutorial we'll see arithmetic operators. Right now we will see how to implement and write a code using a bitwise operator. So for that I am taking an example of 4 to 4 is to 1 mux. So let's switch to the coding implementation part. So here we'll go and let me add one new source file under the same project. So that previous file is of test bench. If you want to learn how to write a test bench, then you can prefer the previous videos. So here we are creating a mux 4 is to 1. Okay, then click next and finish. So your module is created. We will remove the files that are not required. So we will declare some inputs and output ports. So module will have one out, I0, I1, I2, I3 as the input lines, and S1, S0 as the select lines. Then here we will define what is the output. So out is the output variable and input is this all. Ultimately selected lines are also input lines. So this all are the inputs. So we'll assign out as such is equal to bracket. So this symbol is for negation. So if S1 is 0, and S0 and I0, or so variables will keep changing. So we are implementing it using a logical bitwise operators. So the second logic would be S1, that is the 0 1, and I1 is supposed to be the output, or 1 0, I2 is to be the output, or 1 1. If S1 S0 is 1 1, then I3 is to be the output. So 0 0 output is I0, 0 1 output is I1, 1 0 output is I2, and 1 1 output is I3. With operation will end over here and end module. Let's save it. Fine, it is saved. And then let's synthesize it. So in the implementation, first we will change it into top module, right? So mux changed to set as top module, yes, and then we'll synthesize it. So synthesis is completed. Let's once have a look for its waveform also and cross check whether we have done a bitwise operator part successfully or not. Okay, so let's do it. We'll simulate the behavioral model. Okay, so now let's provide inputs. Here I am giving 1. So select line 0 is 1 and select line 1 is 0. Okay, and here I am providing I0 as 1, apply I1 as 1, apply I3 as 0 I am giving, and I3 also I am giving 0. So first let's see for S0 and S1 the out should be, we'll go to the project navigator for S0 S1 and S1 S0, S0 S1 and S1 S0. So I1 is should be the output. So let's see if we are getting this or not. So I1 is 1 and output we are getting is 1. So we have successfully implemented the 4 is to 1 mux using a logical operators, that is a bitwise operator. For the next tutorial we'll see the implementation using an arithmetic operators. Till then, stay tuned, stay safe, and comment in the comment section if you have any query or if you want to learn some more different logics. So share and like if you like the learning part. Please guys do support, and let's meet in the next tutorial, and thank you so much.